Finding common denominators. As we found in the previous module, division led to a new set of numbers, fractions. In this module, we will be performing various operations with fractions. Let's get started. How many halves make a whole circle? Well, here we have some halves. Let's see. Put that in there, and that one there. So 2 halves make a whole circle. How many fourths make half of this circle? Well, we put 1/4 in here and 1/4 in there. 2 fourths make half of one circle. How many sixths make 1/3 of this circle? Well, these are sixths because 6 of these would fit into this one circle, and each of these pieces are 1/3 of a circle. So if we take 1/6 and 2/6, that would fill up 1/3 of this circle. So the answer is 2. How many eighths can fit in 1/4 of this circle? Well, here's one whole circle, and this piece, this one right here, that's 1/4 of the circle. And if we put in 2 eighths, 1, 2, that would fill up 1/4 of this circle. How many different combinations can you make to fill the circle? All right, let's start over here with 1/2. So we have 1 and then 2, and I'll rotate this one around like that. All right, so it took 2 pieces of the half pieces to fill the circle. Let's move on to the next one. We have 1/3. We have another 1/3. And finally, we have a third piece. There, it's close enough. 3 of these, so 3 of the 1/3. Okay, we have 1/6 here. So let's do 1/6, another 1/6, so that makes 2. We have a third one. Here's a fourth one. A fifth one. And finally, a 6th piece. So it took 6 of these to fill the circle. All right, how about the 1/5 piece? 1, 2, 3, 4, and 5. These ones didn't fit as nicely, but take my word for it, the answer is 5. All right, then we have 1/4 over here, so we have 1, 2, 3, and 4. So it took 4 of these. All right, we have 1/7 here, so 1, 2, 3, 4, 5, 6, and finally 7. took 7 of those. And finally, we have 1/8. So 1, 2, 3, 4, 5, 6, 7, and 8. So it took 8 of these. As you can see, there's a pattern here. Whichever number is in the denominator is how many of those pieces it would take to fill up one entire circle. You can use the set of skip counting sticks to find common denominators for two fractions with unlike denominators. If you don't have a set of sticks, you can create them by listing the multiples of the denominator. For the fractions 3/4 and 1/6, you line up the sticks this way for the denominator of each fraction. So you have a stick here, the denominator is 4, so you take 4 and then you have multiples of 4. So 4 times 2, 4 times 3, 4 times 4, 4 times 5, and so on. And then you do the same thing for 6, because that's the denominator of the second fraction. So in the first square you have 6, then 12, 18. You just keep going for all the multiples. What you're going to do then is just find the smallest number in both of the sticks that's common in both fractions. So here we have 4, 8, 12. Here we have 6, 12. So 12 is the smallest number that both of these sticks have in common. So the least common denominator of 3/4 and 1/6 is 12. LCD stands for least common denominator. Here's a quick way to find LCDs. You list multiples of the larger denominator and stop when you find a common multiple for the smaller denominator. For example, if we're trying to find the LCD of 1/3 and 2/5, you find multiples of 5. So you have 5. Is that also a multiple of 3? It's not. So you move on. 10. Is 10 divisible by 3 evenly? It's not. So you move on. 15. Is 15 divisible by 3? Is that a common multiple? Yes, it is. Therefore, this is going to be your least common denominator. For 3/4 and 2/9, you start with the larger, 9, and you list the multiples of 9. Then you go through and you see which one's a common multiple for 4. Is 9 a multiple for 4? No. What about 18, 27? Nope, nope. But 36 is. So 36 is your lowest common denominator.